Hi students, welcome to our channel Vagdevi IIT Foundation, JEE Mains and NEET. This is Pradap Naidu, faculty in physics for IIT-JEE and NEET. Okay. Next, our topic is kinematics part 5. In previous part, that is kinematics part 4, I gave analysis regarding the topic kinematics. Okay. So to rectify some misconceptions, now we are going to next topic, that is average speed and average velocity. And average velocity. Before entering into average speed and average velocity, there are some things for us to discuss here. The first one is uniform motion and non-uniform motion. Okay. So, uniform motion and non-uniform motion. Let us know what is uniform motion and non-uniform motion. Suppose this is x-axis, this is origin. A particle starts its journey from origin and reaches a point A here. Okay. Let us divide the time intervals of this journey. 1, 2, 3, 4, this is 5. This is 1, 2, 3, 4, 5. What is this? Seconds. Seconds. Okay. This is the first second, second second, third second, fourth second, fifth second. So what is the total time taken by this one? 5 seconds. Let us suppose that the total journey is some 50 meters. So total distance S equal to how much? 50 meters up to point A. So from here, from origin to point A. So what is total distance traveled by the body? 50 meters. So what is the total time taken here? 5 seconds. Okay. Now let us suppose that the particle moves, the distances covered by the particle in different time intervals. Let us consider. So here the distance covered by this one is 2 meters. 2 meters. Here it is 8 meters. 14 meters. Here it is 16 meters. Let us suppose. So 30, 40. And here it is 10 meters. Okay. See here, total distance is 50 meters, total time is 5 seconds. Let us check in each second. So what is this one? From here to here, 1 second. From here to here, second second. Here to here, third second. See here, time starts here, time t equals 0. So first second ends at this point. Means where first second ends, immediately what starts? Second second starts. So this zone is second second. So here second second is starting at this position and it is ending at this position. Now what is this part? This is third second, because second second is ending here, immediately third second is starting here. Got it? Yes. So like this. Now in first second, what is the distance covered? 2 meters. Second second, 8 meters. Third second, 14 meters. Fourth second, 16 meters. Fifth second, 10 meters. Such type of journey comes under non-uniform motion. Such type of journey comes under non-uniform motion. What does it mean? How can we define non-uniform motion now? If unequal distances are covered in equal time intervals, then such a motion is called as non-uniform motion. Is it uniform? No. In first second, 2 meters, second second, 8 meters, third second, 14, 16, all numbers are different here. So what type of motion it is? It is a non-uniform motion, right? Okay. Now let us check what is uniform motion. This is x-axis. This is origin. This is 1, 2, 3, 4, 5. What is this? Time in seconds. So time in seconds is taken along this axis, right? Now What is the total distance here? The total distance is 50 meters. S equal to from this point to this point. What is total distance? 50 meters. Okay. Let us suppose that in 1 second it covers a distance of 10 meters, second 10 meters, third second 10 meters, fourth second 10 meters, fifth second 10 meters. Now what type of motion is this one? Is this non-uniform motion or uniform motion? This is uniform motion. This is uniform motion. So how can we define uniform motion? In equal time intervals, if equal distances are covered, then such a motion is called as uniform motion. Okay, but is this a definition enough? Is it sufficient? Is it perfect? No. See here, why it is not perfect? Let me explain. Now I am dividing this time interval, first second I am dividing into, see, this is half second, no? This is first second, means here it is half second, so midpoint. Now suppose during first half second, see, in 1 second it is traveling 10 meters, means in first second it can travel 4 meters, and in second, so first half second it can travel 4 meters, and the second half second it travels 6 meters. Is this not possible? Yes, this is possible. This is possible, no? So the same story can be repeated in different time intervals. Suppose here for first half it can be moving some 8 meters, and here it is 2 meters, here it is 3 meters and 6 meters, 3 meters and 7 meters. Okay, this is one, this is another pair, this is another pair, so on like this. So now, is this uniform motion? No, this is not uniform motion. But previously, if I do not partition this time intervals, previously it seems to be uniform motion. That's why, what was the definition I gave you previously? For uniform motion, in equal time intervals, if equal distances are covered, then that type of motion is called as uniform motion. But no, it is not perfect. So how should we change the definition now? A motion is said to be uniform motion if in equal time intervals, equal distances are covered, however small the time intervals may be. Here the time intervals are, what is the size of time interval? Each time interval is 1 second, 1 second, 1 second, 1 second, 1 second, 1 second. The size of time interval is 1 second. When the size of time interval is 1 second, what are the distances covered? 10 meters, 10 meters, 10 meters, 10 meters, 10 meters. Seems to be uniform motion. But see, when we divide the time intervals into equal halves, then what happens? What information we got here? See, in first half second 4 meters, second half second 6 meters. Here in one part 3 meters, in another part 7 meters. Here in first half of the second 8 meters, second half of the second 2 meters. Is this uniform motion? No, this is non-uniform motion. That's why we have to include the word however small the time intervals may be. We should include that word. However small the time intervals may be. So what is uniform motion? Equal distances. So what is the definition of uniform motion? Equal distances are covered in equal time intervals, however small the time intervals may be, then such type of motion is called as uniform motion. Okay. Then what is non-uniform motion? So in equal time intervals, the distances covered are unequal. Here no need to mention however small the time intervals may be. Okay guys, now you got the idea what is uniform motion, what is non-uniform motion, right? Now one more thing is there. I want you to feel what is average value. What is average? What is average value? In one section, there are two sections in a class, section A and section B. In section A, there are 20 or there are 60 students are there in section A, and in section B, there are 80 students are there. And here, one boy is celebrating his birthday and he brought a pack of dairy milks. And how many dairy milks you know? He brought a pack of 180 dairy milks. In this section also, one boy is celebrating his birthday and he brought 320 dairy milks, a dairy milk pack of 320. Then after distribution equally to all students, each student in this section, how many dairy milks he will get? What you will do for that one? Each student, how many dairy milks he is getting? The distribution is uniform. There is no partiality. Okay, he is not giving more chocolates to his best friends, and he is not giving less number of chocolates to his just classmates. He is equally distributing them. In that case, how many dairy milks each student will get here? So 180 by 60. So total number of dairy milks by total number of students. 0 0 cancel, 6 goes 3 times. So how many here? 3. So each student is getting 3 dairy milks. Okay, and in this section 320 total number of dairy milks by total number of students, 80 here 4. So in this section each student is getting 4. If you ask on an average in this section, on an average how many chocolates each student is getting? 3 chocolates. In this section how many chocolates each student is getting? 4 chocolates, and that 3 is called as average for this section and 4 is average for this section. Average means how much amount one unit is getting. What is unit here? Student is unit. What is amount here? Number of chocolates. So each student is getting, see here, 180 dairy milks by 60 students. See, 3 dairy milks. So in numerator dairy milks is there, in denominator student is there. So 3 dm by s. So what does it mean? How can we write this one? 3 dairy milks by 1 student. What does it mean? So each student is getting 3 dairy milks. Here also it is 4. 4 is the average value. Okay, let us consider one more example. Let us suppose a particle is starting its journey from O and reaching this point A. Let us take the previous example. Let us take the previous example here. Suppose this is 1 second, 2 seconds, 3, 4, 5. So T equal to seconds. T is taken in seconds, right words. Along positive x-axis, time is taken. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. And total journey is 50 meters. Total journey is 50 meters. Okay. And let us suppose the distance traveled in first, here in this case it is 3 meters in 1 second, first second. Here it is 8 meters. Here 17 meters. Here 12 meters, and last one is 20, 30, 40, 10 meters. See here, a car is going from point O to point A. What about the distances covered here? In 1 second, first second 3 meters, second second 8 meters, third second 17 meters, fourth second 12 meters, fifth second 10 meters. So from your knowledge, with your knowledge, what do you know here? Is this uniform motion or non-uniform motion? This is non-uniform motion. By definition, you know, because in equal time intervals, the distances covered are unequal, so it is non-uniform motion. We are interested to move our car with a uniform motion. That is, in 1 second, how much distance is covered? The same distance has to be covered in second. Okay, the same distance has to be covered in third second, same in fourth, same in fifth. So in each and every second, the distances covered must be same. So we want to drive our car in that way, that is uniform motion. Now our question is, in each second, how much distance I have to cover? Recheck the question carefully. What is the question? In each second, how much distance our car has to cover? Okay, right. Now for that one, what I am doing previously, what we did, total number of chocolates by total number of students. Here, total distance 50 meters, total distance by total time is 5 seconds, 50 meters by 5 seconds. 5 goes in 50 10 times, so this can be written as 10 meters per second. 10 meters per second. So do you know what is this? This can be written as 10 meters. See, in numerator what is there? 10 meters is there. In denominator, see what is cancelling here? 5 after it is cancelling, what is there here? It is 1 is there here. So in numerator 10 meters is there. In denominators what is there? 1 second is there. So 10 meters per second, it can be written as 10 meters by 1 second. What is the meaning of this? So in each and every 1 second, the car has to travel a distance of 10 meters in uniform motion. So in each second, how much distance he has to cover? 10 meters. Now this can be written as 10 meters per second. What is that? What is 10 here? 10 is average value. Whose average value? This is the average value of distances covered. What is distributed uniformly here? For each second, 10 meters, 10 meters, 10 meters. What is distributed here? For each second, 10 meters, 10 meters, 10 meters, 10 meters. Distance is equally distributed for each second, as dairy milks are uniformly distributed for each student in this case. Here, distances are covered, distances are distributed uniformly for first 1 second 10 meters, second second 10 meters, third second 10 meters, like that. Got it? So here 10 is, what is this? Average value. Okay? So now, have you felt what is average value? Average means justification, distribution equally, average. Okay, justification in a distribution, equal distribution, no partiality. That is average value. So now we have entered this one, average speed and average velocity. Now let us enter into average speed and average velocity. Now let us consider what is average speed and average velocity. Let us consider a point A here. Let us consider a point B here. Let us suppose that a particle moves from A to B along this path. Let us consider a point P here. So let us consider a particle moves from A to B along this path APB. Suppose its length of this path is 50 meters. Now, so this is length of, this is actual path, no? So what is the length of actual path? This is the actual path. Why we call this one as actual path? Because it is the path on which the particle traversed. The particle actually moved on this path. So this is called as actual path, and its length we call it as length of actual path. That is distance. What is distance definition? Length of actual path is called as distance. So this is the length of actual path. So this is equal to distance. This is equal to distance. See, distance I am representing with smallest. And what is the displacement here? From definition of displacement, you know, It is the length of straight line joining initial point and final point B. Here initial point is a final point B. Final point B. So it is the length of straight line joining initial point and final point. What is displacement? Very simple. Displacement never bothers about the path of journey. It bothers always only about initial point and final point. Nothing. It doesn't want any information. It wants only one thing. What is the initial point of the journey? What is final point of the journey? Okay, you want magnitude of displacement? Just join these 2 points by a straight line from A to B in this direction. So displacement is a vector quantity from initial point towards final point. So we put arrow mark here. No? Right. Let us suppose that the length of this path is 30 meters. So what is the displacement here? Displacement capital S. Here speed is a scalar quantity. Speed is scalar, and velocity is, it is a vector quantity. Velocity is a vector quantity. That is, the speed is having only magnitude while velocity is having both magnitude and direction. It is vector quantity, right? So next, what is average speed? Average speed is defined as total distance by total time of journey. Total distance traveled by the body by total time of journey. Let us suppose that total time taken in this case is 10 seconds. Let us suppose that total time taken in this journey is 10 seconds. So now what is total distance here? 50 meters. Okay. By what is total time? 10 seconds. So average speed is equal to total distance. See what we are dividing? We are dividing this distance for each time interval of 1 second. How do you know? So divide this one. 10 goes in 50 how many times? 5 times. So this is equal to 5 meters by 1 second. See here, in 1 second how much distance the particle is traveling? 5 meters. So that is average value. That is average value. 5 meters is average because it is the value corresponding to 1 second. So in 1 second the particle has to cover 5 meters. Okay, that is average value. Now let us check what is the average velocity here. Average velocity. So what is average velocity? It is a total displacement by total time. What is the average velocity? Total displacement by total time. So what is total displacement in this case? 30 meters by what is total time? 10 seconds. So this is equal how much? 3 meters in 1 second. See, what is the average value for distance? Average value for distance 5 meters in 1 second. What is average value for displacement? See, total displacement for this 10 seconds is 30 meters. For 1 second displacement is 3 meters. This is average value for a distribution of distances for each 1 second, and this is average value of displacement distributed to each 1 second. Both of them are same or different? Different. Both of them are different because this motion is not along a straight line. This is not a motion in a straight line. This is a motion in a plane. This is motion in a plane. If motion is in a straight line, then in that case displacement is equal to distance. And there is also one condition is there. The body should not go to and fro. See, check previous videos. Then you can clearly understand in which case distance and displacement will be equal. See, if a body moves in this direction, it should not turn back. So starting from O to suppose A, let us suppose that if a body starts its journey from O and moves towards A along a straight line O to A, then in this case distance, what is the distance? Distance is the length of this straight line. Distance is length of actual path. What is actual path? Straight line from O to A. What is displacement? Same straight line O to A. So in this case distance and displacement are equal. Suppose if a particle moves forward and comes back like this, then what is the distance? Distance is length of this path plus this path. Then what is displacement? Displacement is length of only this small path, because this is initial point, this is final point. So if a body does not move along a straight line, if it moves like this, in this case distance and displacement not equal. Even if the particle moves along a straight line, but if it is changing its direction, that is changing its direction means it cannot go sideways. Straight line motion, it is motion along a straight line means two possibilities are there, either in this direction and opposite direction. Okay, if that happens, if the body changes its direction or reverses its direction, then also distance and displacement not equal. So only one possibility where distance and displacement are equal. What is that possibility? A particle has to move in the straight line in one direction, then only distance is equal to displacement. See here then, what is, if a particle moves along a straight line, let us compare these two things here. If a particle moves along a straight line in one direction, okay, then in same time, if a particle is moving for example, this particle is moving from A to B only. So what is the distance? 30 meters. What is time? 10 seconds. What is distance here? 30 meters only. What is displacement? Same 30 meters only. What is time? 10 seconds. So time is same here, no? Okay. Then distance, total distance is also same, no, here. So this fraction and this fraction, both of them are same. That means average speed is equal to average velocity when the particle moves in a straight line without reversing its direction. Without reversing its direction, if it moves along a straight line, then in that case average speed is equal to average velocity. Don't worry if I use average speed or average velocity in flow. For average speed, if I use average velocity or average velocity, no need to bother if we use average speed or average velocity in this case when the particle moves along a straight line, because here average speed and velocity, both of them are same. If the motion is like this, they are not same. If the motion is like this, going front and coming back like this, then also not same. Speed and velocity are not same. Particle is moving in a straight line without changing its direction, then in that case both speed and velocity, its magnitudes are same only. No need to worry. So got it? What about average speed and average velocity? So what is average speed? Total distance by total time. And what is average velocity? Total displacement by total time. X-axis, origin, this is A to B like this, this is B, this is A. Okay, since it is x-axis, let us suppose that this position is x1 and this position is x2, and the time taken for this journey is some t seconds from A to B. From A to B, okay. Now what is average? What is average speed? Average speed can be written as with this symbol, small v, a bar here. This bar is not for vector notation, it is for average value. It is symbol for average value, or we can write like this also, v average. Okay. So average speed, what is this? Average speed equal to total distance by total time. So what is total distance here? Total distance is length of actual path. What is the length of actual path? Length of, let us take a point P here, length of APB by what is total time? T seconds. So this is average speed. Okay. Then what is average velocity? Average velocity, capital V bar, or capital V, we can write average like this. This is equal to total displacement total displacement by total time. So this is equal to, what is total displacement? Length of, what is total displacement? Initial point is A, final point B. What is total displacement? AB is total displacement, no? So length of AB. See, AB means it is a straight line, length of straight line AB. See, here it is APB means this curved path. So length of AB by total time. So what is the length of AB? From O to here, this length minus this length. From this length, remove this length, you will get this one. So what is this length? X2 minus what is this one? X1 by what is total time? T seconds. So X2 minus X1 by T seconds, or we can write this one as delta X by T or delta T. Okay, that is the total displacement delta X by delta T. Or in books, some books you can find like this. Don't worry, you can find like this. This is S1, this is S1, and this is S2, this is S2. Therefore in the place of X2 minus X1 they will write like this also. Average velocity V bar equal to S2 minus S1 by delta T. Don't worry. Here we have taken in terms of positions. Position of this one is at X1, position of this one is at X2. So S1 means what? They are taking in terms of displacement. So first initially the object has made a displacement from O to here, that is displacement S1. Here displacement S2. Okay, so final displacement minus initial displacement S2 minus S1 by total time is delta T. So no need to worry. Okay, so got it guys? Average speed and average velocity. In next video I will give you some numerical examples. Let us meet then.